In this lesson, I'll be showing you how to put together some of the things that you've learned to achieve some simple tasks using Spark. I hope that this will help you understand better when particular transformations or actions are appropriate, and provide some starting points for when you want to do your own things on your own data. One of the common examples for many big data technologies, Apache Spark included, is the task of counting how many times individual words are used in a set of text files. So we're going to look at the same subset of the Gutenberg corpus here, just the first 1,000 or so ebooks. We're going to count words, so what we have to do is turn our RDD of ebooks into an RDD of words, which we can do with a split, making a list, and flat map, aggregating those lists. Then the trick for doing a word count is to take that RDD of words and turn it into an RDD of word1 tuples, then reduce the RDD by key, summing the values. So first of all, I bring in the data into my texts RDD, and then once I do that, I run a flat map with an inner function that splits the texts into words. I take the lowercase of each word, combine it with a 1 in a tuple, and then reduce the resulting RDD by key, summing the values. In the end, to trigger the computation, I collect those results into my results variable. While that's computing, what can we do with the results? We're going to get a list of word count tuples, so we could sort that list by word to get the word counts in alphabetical order, or we could sort it by the count, reversed, to see the words in frequency order. Let's take a look at those. Alphabetical order first. So, taking the first 30 words and printing out the word and the associated count. It takes a few seconds to sort, but then we see some results, and they might not be what you expect. Have a think about how those results might have happened while we set off the equivalent in count order. Again, taking the first 30 results and printing them out. Well, these results are a little bit easier to understand, but where are those 470,000 instances of the word TT coming from? These little runs, on a subset of the data, are a good illustration of the difficulties in big data of dealing with variety and veracity. Although the typical use for Spark, along with the rest of the Hadoop big data stack, is to start by crunching large datasets, it's possible to do more traditional parallel computing as well, by distributing computational work to as many processes as you have in your cluster. We can use this, for example, to run random simulations in parallel and collate the results at the end. To show you how that works, let's do pretty much the simplest meaningful random simulation to estimate the value of pi. The trick is to imagine choosing a point, say by throwing a dart, inside a square. We know the square's area just by multiplying its side lengths together, and the area of the circle that just fits inside it is pi over 4 times the area of the square. This is a random simulation, so we need to import the random module. And then after that, we're going to define a test function that will tell us whether we are inside or outside the circle. So we generate 2 random numbers and test whether the sum of their squares is larger than 1. If it is, we return 0. Otherwise, we return 1. What we're doing here is defining a function that takes 1 argument. You'll see why in a minute. Generates 2 random numbers between 0 and 1 to represent the point in the square. If that point is inside the circle, the function returns 1. Otherwise, it returns 0. Then we can use this function with Spark. I'm going to generate an RDD of 1,000 elements, map that test function over it, and then take the mean of the resulting dataset and multiply it by 4. So here we're generating a 1,000 element RDD with the numbers 1 to 1,000 in it, but that doesn't really matter. We just need something. Then we map our test function across that RDD. That's why it needed to take an argument. And then take the mean over the resulting RDD. To get our estimate of pi, we need to multiply the mean of the RDD by 4, because each element of the RDD is a single estimate of 1/4 of pi. A couple of caveats with this example, though. Firstly, you might find that when you scale it up, the mean action is slower than you might expect, and that it is faster to use sum and then divide by the number of iterations afterwards. Perhaps more importantly, because of the way the worker processes are constructed, you might get the same answer each time you try this, rather than new random samples, as you'd hope. You can use the map partitions transformation to run something, for example, a function to initialize the random seed, once on each worker, in order to get independent results each time. In this lesson, we've gone through a couple of simple examples of using Spark for distributed computation. The simple word count on a subset of the Gutenberg e-texts, which revealed some questions about the data, and a randomized method for estimating pi, which highlights the need to be careful when using random numbers.